Objective 5 and 6 to deal with mapping. Right? First definition you need to know when you talk about maps is a field. I don't mean a farmer's field. Right? Don't mean a field where the cows are walking. What we mean by a field is a map. Right? It's any area of space that you can measure a quantity, so there's something measurable, at any given point. For an example, probably have heard of a gravitational field, gravity. So that if I look at an example of a gravitational field, this is for Earth. You can see down here that the gravitational field, they use different colors. Slide it up so we can see it a little bit more. Red and orange are going to be higher gravity. Blue is smaller. So that any place here in this field, you could measure gravity. Or if you drop an object, it's going to go towards Earth because you're within Earth's gravity, Earth's gravitational field. So that means at any point you could measure gravity on that diagram. Over here is an example of what a field would look like. Right? The one that I showed with gravity was with colors. Well, we're going to have a hard time using lots of different colors, so instead we draw lines. This is showing a temperature field map. There are lots and lots of different types of field maps. Magnetic field, atmospheric pressure that we use in weather, relative humidity that we'll also use during weather, temperature, although those are very important in weather. How about somebody with allergies? Want to know the pollen count. How about in the middle of winter? We want to know the snow cover or how deep the snow is. So all of these are going to be examples of fields. So if I just pick on, let's pick on pollen count just to see something a little bit different. Scroll down here, I can find a map. There it is. And they're telling me, again, this is colors. So that green is low, red is very high, so you can get a sense of where the pollen is going to be bothering people more. So that is a field, right, that can show any of these quantities. So at any given point, you could measure any of those. And I'll just show maybe another one, magnetic field, right, that they have all of these lines on here. This is from the Mars Global Surveyor, so they're showing the magnetism on Mars. And then between the lines, we're using different colors, red and orange to show higher magnetic field, blue to show lower. So all of these that I'm showing you all have different colors, right? But let me show you one that doesn't have colors, atmospheric pressure. You may have seen one of these before on Weather Channel. Right, when you study the weather, they show the H's and the L's to show high and low pressure. And you can see these white lines on here that are going around and connecting the pressure values, the measurements that were taken at any given point. And then from there they can draw fronts, they can show you where the cloud cover is, and they can put a weather map together. Right, so this is a field. When we discuss field, they're going to know how to create one. The first thing you're going to do is draw isolines. A line just goes and connects points. Iso means the same, so the definition for an isoline is a line that connects all of the same points. Here again would be an example of what one would look like. So you go around and you connect all the 5s, or you go around and you connect all the 10s. You actually create a map, a field, using those isolines. Now isolines is the broad category. There are 3 specific types of isolines, or examples. First one, isobars. In order to discuss isobars, I want you to focus on that part, the end of it. That is from a word that you may have heard of before, a barometer. Is there anybody that knows what a barometer measures? If you know that a barometer measures pressure, then you would know that an isobar is a line that goes around and connects all of the same pressures. So there's your definition for an isobar. Again, the keyword barometer. Feel free to write that in next to it. So here's that map that we were just looking at from the Weather Channel, where you see all of these lines that are connecting pressures. So therefore, all of these isolines are called isobars. Next one is a contour line. Contours measure elevation. So you would not see this necessarily in weather, right? What you would see is lines that go around and connect all of the points of the same elevation. So here is a topographic map of Clayton. You can see French Creek Bay, and if you were to look closely, you'd see all of these different contour lines that are going around and connecting the elevations around Clayton, New York. And the third type of isoline is an isotherm. Notice I'm underlining therm. So with this part, instead of a barometer, now I am focusing on thermometer. So what does a thermometer measure? Nice. Temperature. So an isotherm is a line that goes around and connects all of the same temperatures. Isotherm. And then here's an example. They're using the lines, and in between the lines they're coloring to show the different regions of the country where there's different temperatures. So you will practice a lot drawing isobars, contour lines, and isotherms as examples of iso lines. 3 different types. Now when we draw isolines for a field or for a map, it represents images in 2 dimensions. So like this flat map, all of these isolines are showing elevation, but it is a flat isoline map. Or as another example, here is a topographic map around our school. And when I hold it up and you look very closely at the isolines, you'll do this in a lab activity, you can see it's a flat map, a flat sheet of paper. It's 2-dimensional. That's what isolines are. Isosurfaces are different. Isosurfaces actually pop out at you. They are in 3 dimensions. So here's an example showing a 3-dimensional isosurface. Here's another example of a model that's an isosurface showing a hill, actually probably like a volcano because there's a crater at the top, but yet this is 3 dimensions. Here's another one that I'll use when we get the glaciers. You can see the mountain peaks, you can see the glacial valleys. This is in 3 dimensions, this model, so this is an isosurface, not isolines. It's not a field map, but it is a 3-dimensional model, which brings us to the term model. When we look at isoline maps and isosurfaces, these are all examples of a model, just like a globe. A globe is a model. And you say, well, what is a model? All it is a simple way of representing something else. So this is a simplified representation of Earth. I just held up this isosurface that was a simplified representation of a glacier. So a model is just a simple way of showing something, of representing some object or some structure, something that's a little bit more complicated. We try and simplify it. Those are models. When we study models and maps, there are 2 other important vocab terms that you're going to have to know. Static means unchanging. So if you were to look at this graph and you were to look at the orange line, you can see that it is staying the same going all the way across. Right? That has an unchanging or a static slope. Whereas dynamic means constantly changing, kind of like this graph down here. So I ask you, of these 2 terms, static and dynamic, which one is going to represent almost all fields? So if I go back to the slide where we're looking at the magnetic field or the gravitational field or the pressure field for the weather for today, if you were to look at weather maps, are they going to be unchanging, static, or are they constantly changing, dynamic? I certainly hope you just picked dynamic, because when you measure things and then you go back the next day or a week later, there's no guarantee that they will remain the same. So therefore these maps tend to be dynamic, always constantly changing. And then what we will do is we will practice in class objective number 7, which introduces one last vocab term for you on this page of notes, which is gradient. Right? Another way of saying gradient is the steepness or the slope of a surface. So when you look at a map or a field, the average slope within that field, how much it changes from one place to another, is referred to as gradient. And what we will practice tomorrow in class is there is a formula on page 1 of the Earth Science Reference Tables that you have to know. Gradient is equal to, make sure you have the equal sign, okay, the change in field value over distance. That is the equation. Please write that into your notes. And then I'll explain how you find this top value, how do you find the distance, and then one over the other, the math means you have to divide so that you can find the gradient of a location. Sometimes you don't have to do that. Sometimes people can just look at this picture and go, wow, look how flat it is. It has a very low gradient. It's not very steep. The slope is not very large. Here, you can see, wow, the mountain peaks, and you can see where it drops off. You'd say this area has a steeper gradient, a larger gradient. So the gradient can change based on the characteristics of that land.